for the second part. Hopefully you can take care of the connectivity issues in the edit. Great. Well, good evening, everybody. Great to be here. My name is Matt Adams. I'm currently the Head of Security Enablement at Citi. And in that role, my team focuses a lot on securing generative AI solutions, along with other emerging technologies like blockchain, DLT, quantum to some extent as well. We look at that. But by far, the majority of my time is spent on generative AI, as would be appropriate for the current buzz in the industry. But my journey with generative AI goes back a lot further than my career with Citi. And I looked at probably around GPT-2, I started kind of being quite interested in what was being cooked up in the various AI labs. And it was funny, it showed some promise, but I don't think you couldn't yet sort of really see the potential, or if there was potential, that was all you could see. And then you sort of saw maybe October, November, a couple of years ago, GPT-3 came out, and suddenly it was putting coherent sentences together. And then GPT 3.5 and ChatGPT came out, and all of a sudden I thought, this is something that really works. And pretty shortly after that, I started working on this project, STRIDE GPT. So what I'm aiming to do this evening is to give you a bit of a potted history of the project and also show where it is as of today. We will wait for the technology. There we go. So that's our agenda for this evening. I'm just going to do a quick level set. I think we're all security people, or at least most of us are, but not all of us will be using the same threat modeling methodologies. So I'll take you on a quick run through STRIDE. We'll then introduce you to the tool itself. I'll talk about some of the key features and recent updates that I've made. We'll then focus on some live demos, because I think that's the most interesting thing and risky thing from a presenter's perspective. And then I'll just talk about some of the adoption and impact that I've seen from what has been, just a little pet project of mine. I've been quite surprised how widely it's been adopted and the enthusiasm that we've seen from the community. We'll wrap up with some future plans and then leave some time hopefully for a bit of Q&A as well. So a quick level set on STRIDE. Other threat modeling methodologies are available, but those of you that know STRIDE will know that it's incredibly popular. And one of the key reasons for that is its simplicity. So there are these 6 categories, all the way spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. And you can see here on the key, these are what these things are dealing with. I think most of these are self-explanatory, particularly to those of us in security. The ones that tend to trip people up are things like repudiation, which is the ability for somebody to deny a wrongful action. I think the rest of them are pretty straightforward. Elevation of privilege, maybe. So trying to take hold of access rights that you don't have. And where this methodology was used, I think it was originally created by Microsoft, because they were one of the companies that first started to really think about how do we identify what can go wrong in large software systems. But why this is popular is, as I said, the simplicity, but also because it covers a good portion of the different attacks, and it seems to work well across loads of different types of systems. So if you break them down to these main 6 categories, and then you've got a lot of your key threats covered. There's a more recent innovation as well, STRIDE LM, which incorporates lateral movement. Might be something I'll bring to the tool in the future, but for the moment, it just focuses on the core 6 categories. So the concept for STRIDE GPT really came from that light bulb moment when I was playing around with ChatGPT, and I thought, how can I use this to solve some problems in security? And one of the things that immediately came to mind was threat modeling. Now, I'm a security architect, a security consultant by background. I've been in the industry for about 20 years, and threat modeling is always one of those things that I've seen holds tremendous promise. Those organizations that do it well, I think, really benefit from doing it, but by God, it doesn't scale, right? So I think some organizations have budgeted for doing like 500 security architects to do threat modeling at scale until they worked out how much that would cost and how many hours it would chew up. So myself, I've lost count of the number of half-day sessions that I've spent with development teams, breaking down an architecture, thinking about what can go wrong, seeing that aha moment from the developers when they understand that we're not talking about what is the functionality of this tool, or at least what is the hopeful happy path functionality, but how can we break this system? How would an attacker break this system? And what are the threats that we're looking for? And my experience is that, particularly if the teams haven't been through it before, they struggle with that mind shift because they're very focused on functional requirements. They're looking to deliver a product that the user will want to use and enjoy and get value from. And to shift that mindset and to think about threats is a real challenge. And you normally need a security person in the room to do that. But I thought, well, maybe rather than putting a security person in the room, we can put a large language model alongside the developer. And what this does is it really achieves these four things. So it really helps to empower non-security experts. So rather than having a security architect or a security officer in the room leading that discussion and being involved from the start, this tool allows developers to go away, go through their development process, run this iteratively, come back, think about what they've done, how it might be improved. And they then come to any follow-up discussion with the security architect, which is much more than a review relationship, kind of a review and edit dynamic, than it is a person in the room leading that discussion. Oh, sorry. Might need to go a bit quicker then between the slides. Okay. Yeah, so it becomes much more of that review relationship, which is a lot more efficient from the security architect's perspective, saves a lot of time. And that's hence the efficient use of resources. It also then, it becomes, because of that dynamic, it becomes a lot more collaborative. So the developers, I think, feel a lot more ownership of the security issues in the tool or the potential threats to that system. And as I mentioned, you also get this iterative refinement. So what you'll see when we go through the demos is that you not only get the list of threats, but it also then offers suggestions, because it can say, if you gave me this extra information, this is how I could improve the threat model. So maybe if you've not talked about any of the authentication mechanisms for a system, it might call out and say, well, if you told me if you're using like OAuth, single sign-on, whatever, we can then think about how that part of the system might also be compromised. Over. There we go. Right. So the key features, and these are pretty consistent from release to release now. I support multimodal threat modeling, so you can provide diagrams into the tool if you're using a multimodal model, so one that accepts images. It will also do things like, actually, no, I'll come on to that in a second. It will generate attack trees, so not strictly part of the STRIDE methodology, but an adjacent technique. It's very valuable from breaking down a system and thinking how it could be attacked. It also then gives you the opportunities to take your existing list of threats and generate a corresponding list of mitigations for those. So you can either think about mitigations that you might want to include or check off the ones that you already have in place. Another Microsoft methodology that they developed is DREAD. This is a risk assessment, and you'll see the kind of scoring that goes on. Again, very popular with the teams that use it. And lastly, there's an ability to write test cases for testing these different threats and where they've been mitigated. So some recent updates, and I really use this as a way of building my own knowledge about different developments that are going on. So STRIDE GPT existed before there was structured output from language models. And when OpenAI introduced JSON mode, I built it into the tool because I thought, well, maybe I can use that in some way to improve the consistency. More recently, we've had reasoning models. So I've been thinking about how do I build in that reasoning capability? Is it useful for threat modeling? Isn't it required? And how would we show the thinking process? Is that useful to the user to understand what the model is thinking about when it's generating a threat model? That all goes into the tool. We've also had a number of people who want to run STRIDE GPT locally. So I provide STRIDE GPT in a Docker image. It also supports integration with local LLMs running through either lu.ma or LM Studio. Both are amazing tools. If you haven't tried them, please do. I also recently added a feature where you can use a GitHub repo as an input to a threat model. So if you really can't be bothered to go through the process of thinking about how a system is put together or writing down the description, you can just point it to a repo URL. The language model will then describe the system based on the code it can see, and then you can take that through to your threat model. I've also recently really worked hard on improving the attack tree diagram generation. So that uses something called Mermaid, which is great for taking language model text output and generating diagrams from it. So it will generate things like flowcharts and decision diagrams. It works really well for attack trees, but language models really want to generate JSON. They're very good at it. They've been specifically trained to output in that format. They struggle sometimes with other syntax types, and Mermaid is one of those. So while it will do it most of the time, it doesn't always do it reliably. So I changed this in the last release to go for a two-step process where it goes from output from the LLM, so where it goes from outputting JSON from the LLM and will then take that and programmatically turn those JSON objects into Mermaid syntax. And then lastly, I also worked hard to improve some of the JSON output handling as well across all of the model providers. So as I've been adding different models, they were a little bit out of level, and I've brought those all together now, and they work really well, even for the local language models. Right, so we're going to run through a few demos. We'll probably just keep going and see how many I can get through. We won't be needing the videos. Oh, right, so this is a current development version that I'm running. So I'm running it on my local machine, and that will do a few things. We'll use Grok. So this supports a range of different models. We could use the lu.ma. I think I'm running lu.ma at the moment, and you can see it will do things like it will load in the list of models that are currently running on the machine and are available. So it checks the lu.ma API and will pull automatically the models that are available. Does the same for LM Studio. But because we're wanting to go pretty quickly, I will use Grok. There's a .env file, so an environment file on the machine. If it's there, the API keys get automatically loaded. And as well as this, we can then select from the models that Grok are making available. We'll use DeepSeek because it's pretty popular and in the news. And the Grok inference speed is insanely quick. So even for a thinking model, we'll get the responses back in a few seconds. So there's just an example description here that we use for testing. So this is a web application that allows you to create, store, share personal notes. The application is built using React. It's got a Node.js backend, a MongoDB database, and then we're trying to give it some additional complexity here. So we're starting to talk about how the sign-up process might work, so they can use OAuth 2 with Google or Facebook. We then think about how the notes might be stored, and the collaboration elements of those as well. And you can put in whatever you want, and we'll probably get onto the GitHub repo one as well, that you can see how that works. But this is good enough to produce a basic threat model. There are some other aspects just to really to prompt the user into providing this information, because it's quite useful to inform the language model. So we're saying that it's internet facing. This is to give a basic understanding of the classification. I don't think it has a huge effect on the output, if I'm honest. But what would do is if we say, like, we have OAuth and maybe we support MFA for some sensitive operations. And then we hit generate threat model. So this will take, yeah, it is really quick. So something that would have maybe taken maybe an hour of discussion, you can very quickly get to a list of very, I think, quite understandable and credible threats. So it's picking up on the information that we provided. So you can see here, we talked about OAuth 2 tokens, or we talked about OAuth 2 as a technology, and it's pulling out then that an attacker could steal the OAuth token and use it to access another person's notes, leading to unauthorized access. We mentioned that there was some collaborative note editing, and it's picked that up in the second threat. We mentioned the particular technology of Node.js, and that's pulled out that there's a tampering risk associated with that. If an attacker can point to that, if we can pick up on that particular risk, and I can see MongoDB in there as well. So that's a good list of threats to be getting on with. I also then mentioned that there are the improvement suggestions, and this is where the iterative part of this comes in. So it's then saying, well, if you can provide more information about the encryption methods that are used for the data in transit, then we can then assess or better assess the man-in-the-middle attack risk, as an example. We've then got an attack tree. So this is the mermaid syntax that I mentioned. So this is defining a top-down graph, and it's then thinking about the different ways that the application could be compromised. So it's not following the STRIDE methodology, so attack trees are a separate methodology, but it's still useful for breaking down a system and thinking about how it might be attacked. Hence I included it in the tool. And you can see then that we've got, you can gain unauthorized access sensitive data, or compromise the database. You can then download this code. You can take it into Mermaid Live, which is an online tool, and yeah, just look at the attack tree and think about how it might inform the controls that you generate in the next phase. So mitigations, and this is where the structured output, the JSON mode, really helps, because when we generated the threat model in the first phase, we also generated the improvement suggestions. Don't really care about the improvement suggestions for the rest of the workflow. So those are generated as two separate JSON objects. And then all of these phases, like the mitigations, the dread assessment, and the test cases, they all just use the top table. And so we've taken that top JSON object, passed it back to the language model, and said, come up with a list of recommendations. You can see here that because we're using a thinking model in this case, or a reasoning model, we're just giving the user the opportunity to get an insight into what the model is thinking about when it's assessing these types of threats. I think this is just really interesting to see how these models work, and what they are, quote unquote, thinking about when they're working on particular requests. And you can see there we've got a markdown table generated, and we will get here a list of mitigations. So the formatting is slightly off, I think, probably because of DeepSeek has wrapped this in a code block. But you can see then it's then suggesting for that, again, for that first one where it's talking about OAuth 2 tokens, you can have a short-lived refresh mechanism, use token binding, you can encrypt tokens at rest, or you can implement PKI for mutual authentication. They're all very sensible mitigations, probably some that you wouldn't immediately think of when you're going through this, unless you're really familiar with OAuth 2 and defending it, but are really helpful starting point for teams to then think about, have we got this covered, or are there additional things that we should be thinking about? If we move on to the dread assessment, so the purpose of this, if you're not familiar with it, is to kind of balance a more qualitative risk assessment with some quantitative numbers. So for each threat, so again, we're reusing that output from the first phase so that we're maintaining the consistency of the model. For each threat, you can see that it's scoring against these aspects. So damage potential, reproducibility, exploitability, and so on. That's where the DREAD acronym comes from. And it's a very simple process of taking the mean average score from all of those, and that then gives you your prioritized list. If you're talking about a risk management decision, which ones should we focus on addressing first? Which ones should we be really worried about? There's a lot made of language models not being able to do maths. And I don't trust the LLM to actually calculate the scores. So we do that programmatically, or the average is calculated programmatically. I think it actually does quite a good job of estimating things like the scores for the damage potential and the exploitability in the other categories. Where I don't trust it is then calculating the average of those scores. So that's done just in Python. And obviously, if you were then deploying this in your own organization, it's open source, so you can then tweak these, you can update the prompts. So if you care more about internet-facing systems, and you think that would have a much higher damage potential, you can then update the prompts to kind of skew that upwards. Likewise, if none of your stuff is deployed with any kind of internet-facing aspect, you can update the prompts again and say, well, actually, this has got really low likelihood, we don't care about it, and so on. What this is trying to do really is just to prove these concepts and how language models can be applied, rather than being kind of the finished product in terms of a threat model. And finally, test cases. So some teams will use Cucumber or Gherkin to go and write provable tests for whether a risk has been mitigated. So you might have identified, for example, that data is stored in an unencrypted DynamoDB instance on AWS. So you could then, as a development team, write a test that will check your AWS configuration, however frequently you want to do that, and we'll say, we'll prove none of our DynamoDB instances are deployed without data at rest encryption. So that's a provable test that you can programmatically check. And if you see one of those flip the other way, you know that you've got a potential security incident. And so that's where this test cases is really getting to. So for each one of these, it uses a very specific syntax of these verbs. So given effectively a condition, so given that the user's OAuth token has been stolen by an attacker, when the attacker then attempts to access the user's notes, then the system should detect. And so this and is conditional, and the user should be notified. So you can then check to see if your processes are following that by expanding that into the actual code that you need. But this is a really good starting point to think about how you would prove if these threat mitigations have actually been implemented in your systems. And then just to take a slight tangent, because we can now scale threat modeling by using these types of tools, and you can now potentially threat model every system in an organization, you can then build up a true enterprise threat model for your organizations. And you can also write test cases for all of those threats and where they've been mitigated. You can really have a good chance of achieving a known security state at any given time. So if a regulator or a supplier or somebody else comes to you asking, have you addressed the threats within your risk appetite? I think this shows some of the potential that you could, how you would answer that question in the future. How am I doing for time? Somebody can. Okay, perfect. Right, we'll just do a very quick test here. So we'll stay with Grok. Just wanted to show you the GitHub integration for the truly lazy threat modeler. So this is another open source project of mine. I put this together a long time ago now, actually, before agentic AI was all the rage. And what this does is it looks at a honeypot and it uses an agent to monitor that honeypot. If it sees somebody connecting to that honeypot, it then updates the configuration of a reverse proxy, which I'm using as kind of like a firewall in this sense, to block the IP address of the machine that connected to the honeypot. So it's all automated. You can deploy it in a Docker container, Docker Compose. I think it's quite an interesting project. But for our purposes, it will be our guinea pig. So as soon as we enter that, again, blindingly fast inference speed, it's then pulling in the repository. It then pulls the README, because that's hopefully, the developers have done a good job of documenting the key aspects of the project. But it will also then do things like look at the imports that are being used within the code. So you can see, like here, we're importing the Microsoft AutoGen agent project. And it will then use that information as part of the threat model. So I won't change anything else. I'll just hit go. It's a bit longer now because we've provided some the README file and some other documentation. Bearing in mind this is a public-facing demo that you can use. So yes, this is running on my local machine, but you can go to Streamlit Community Cloud, and there's an instance there. I've done things to manage the context window because I don't know the size of the input that the user's going to use. And I don't want people raising issues on GitHub to say this errored because I tried to put in, I don't know, the whole of the OWASP project or whatever that you might be using. So that's why it's only doing things like pulling out the imports and the README file. Again, you could change that with the prompting and the ingestion mechanism so that you could then pull in potentially everything about a project. So if you're using something like a Gemini model, 2 million token context window, you can fit a lot of code into that and include that within your threat model. But here I'm taking a couple of shortcuts. And so then just to look at the threats, again, to give you an idea. So you can see here, it's picking up the specifics of the honeypot. It's identified that I'm using a .env file. So could it be altered? And some interesting stuff here. So you could use fake IPs and HTTP requests, and then exploit that lack of authentication in the forwarded for header. So it is looking at the description. It is understanding what the project's about, and it's then thinking about what are the threats associated with this project. Right. So just a quick bit on the adoption impact. I know there's a startup in this space that are charging for this capability or something very close to it, and they said they haven't come across a team so far that hasn't heard about this project, which I find quite mind-blowing. And amazing feedback from the community, which makes it all worthwhile. And again, I looked at these stats last night. So there's been over 18,000 unique users. This is pretty typical, where we'll see multiple new users every hour or so. And GitHub just keeps on going in terms of the numbers of stars and forks, which tells me that people are finding it useful. Some ideas for the future. I'm thinking about pulling everything into a single export format. just making it easy to run through. Currently working on support for the latest Claude model that was released yesterday. I'd quite like to enhance the threat modeling from the code base. So I think the models are at the point where we could probably iteratively go through a GitHub code base and pull out more valuable information. And of course, if you've got any ideas, then you can look the project up on GitHub, raise an issue, and I'd be happy to work on it.